Hi again, Sushmita here. Welcome to Start Study and Go. Aji kon purchu hame scalars and vectors ro part 6 re I am going to teach you what is cross product. It is also called vector product. So I can also write it here as mention it here as vector product. Okay. So cross product or vector product. We will also learn about its properties, which all properties holds good here in this product. And in the meantime, we will discuss about right hand thumb rule, which is very essential. So without losing any time, let's get started. As I have written here, cross product of two vectors will be the product of the magnitudes of the two vectors and the sine of the smaller angle between them. It is always smaller angle. In dot product it was cosine of smaller angle, but in cross product it is the sine of the smaller angle between them. The product will have the direction perpendicular to the plane containing the two vectors. So I must show you how it would be represented. So if there are two vectors like this, A and B. This is B, okay? This is A and this is B. Then what will be the product of these two vectors? These two vectors, when they will be given by cross product, they will give AB sine theta. Sine theta will be the smaller angle between them. So this is it. And the direction will be perpendicular to both of the vectors. So it would be like this. The direction of the resultant vector will be like this. If I denote it as C vector, so A cross B. The symbol of cross product is cross, okay? Vector symbol of cross product or vector product is cross. That's why A cross B, if I read it as this, A cross B will be AB sine theta C cap. What is C cap here? C cap is the direction mentioning the C vector, okay? It will have the direction perpendicular to the plane containing these two vectors A and B. Okay, so this is the first understanding of cross product. Product of magnitudes of two vectors and the sine of the smaller angle between them, and the plane containing these two vectors, the direction of the resultant vector will be perpendicular to the plane, not to these two vectors. It will be to the plane where the A, B are contained. So this is cross product of two vectors, okay. Here I want to mention that cross product is generally governed by right hand thumb rule or right hand screw rule. All are same. I am going to mention you how that works. But before that, it would be wise to understand what are the properties of cross product. Cross product आमे बुझी गले जे गोटे प्लेन रे दीटा वेक्टर अछथि हम जदी क्रॉस वेक्टर नोचे क्रॉस करूचे से मानकु A cross B will be AB sin theta with the direction perpendicular to the plane containing these two vectors which are having cross product. Okay, now tapare ame we will go to the properties of it. It would be better for us to understand first if we have some example beforehand. Now first example will be torque. You may know what is torque. I know that you have certain idea about torque. That is actually represented by tau with a vector sign. It is a vector indeed with a direction. And what would be the direction? It is actually radius into the distance from the axle and the force applied. So it is the cross product, okay. Similarly, another example is angular momentum. This is also a vector. You can see the vector product is always a vector. But in dot product, we have already seen that the dot product is always a scalar. But here you can see that the vector product or cross product is always a vector with a direction sign, right? Similarly, also with angular momentum, what is that mentioned as? If I mention it as L arrowhead, it will be R vector cross P vector. Similarly, with linear velocity, which I will explain in terms of angular velocity, that would be, if linear velocity is, we know, is V arrowhead, it would be angular velocity into radius, which is also a direction vector. So these are all examples of cross product or vector product of two vectors, which is also giving rise to a vector only in each case. So this is the example. Now properties, we will discuss about properties of cross product. Cross product is non-commutative. What do you mean by that? If I write A cross B, it would be never equal to B cross A. Why? Let's discuss. I am going to prove you that A cross B is not equal to B cross A. Let's see how it happens. I am taking another page, I am going to write it down. A cross B, as a picture is suggesting, if I draw a picture like this, this is A vector, this is B vector, then I am having the resultant in this side, right? And this is the angle between them. If I am writing A, here B, this will be C, right? So the you can see the direction is upward here. So let's, I am writing here AB sine theta upward sign. Now I am going to solve B cross A. What it would give? You think so? Now when I am going, when in the first case A cross B, it was, the angle was in this direction and the perpendicular was obviously in the upward direction. When I am going to same diagram I am drawing, this is B and this is A and this is the angle between them. The orientation is this side. So what do you think? What will be the perpendicular? The perpendicular and the direction will be in this way. So I can mention it as D if I want. Obviously. So if I write the magnitude and the direction, it would be, of course, my magnitude is same as this one, but it would be, direction would be downward side. So I can simply say that A cross B is not equal to B cross A. I can simply write. Or I can say is A cross B actually is equal to minus B cross A. It can be written as that. So actually cross product is anti-commutative or non-commutative, and this is another formula we are having proving that they are not equal. Then let's go to the second one. Cross product is distributive. What do you mean by that? Distributive? Distributive means that if I write distributive means what? A cross B plus C. If there are three vectors, B and C are added up and they are the sum of the two vectors having a cross product with A. So what will happen? I can write it as A cross B plus A cross C. You cannot write it as C cross A. As we know, the vector product is non-commutative. You have to write as it is going jaha pore lekhibar ache semti hi lekhibo, like A into C, not C into A. That would change the solution of it. Okay, so it is distributive, of course, but you have to keep in mind that it is non-commutative. Third one is cross product of two parallel vectors is 0. How so? If I am going to write A cross B, what I am going to write? AB sine theta. What is theta here? What is the angle between them? I am telling two parallel vectors. Parallel vectors mean I am going to write it as, if there are two parallel vectors, then what is the angle between them? As you can see, if A and B are parallel to each other, what will be the angle between them? It is of course theta equals to 0. If theta is 0, then sine 0 will be 0, of course. So the cross product of two vectors which are parallel to each other will be 0. Okay, that's what I have written here. So cross product of two parallel vectors is always 0. This is a very good question for MCQ and many type of application based questions. So you must remember, if two vectors are parallel, then their cross product is 0. Okay, then we will move to the next one. The cross product of a vector with itself is 0. That is also obvious. If I am taking a vector A, then I am taking the cross product with the vector itself. Now I can see it would be 0, of course, because there is no, if I am writing AA as the magnitude, although I am writing the magnitude here, the sign is also 0 because there is no angle between the vector with itself. That's why it would be 0. So this is also a fantastic question for your application based question. Whenever there is a vector having a cross product with itself, it is always 0. Then we will go to cross product of orthogonal vectors, which is an important thing to understand, because we need to deal with vectors in their Cartesian coordinates in 2D and 3D as well. So if I am going to write two vectors A as AXI plus AYJ, right, in 2D form it would be. Okay, so that means a vector, if the vector is like this, I am resoluting in two components, x and y component. This is A vector and this is AX, this is AY, right? All are vectors. And IJ are orthogonal vectors. Now, if I am going to write B in 2D also, it would be BXI plus BYJ, right? Now, let's take the cross product of both the terms. What it would be? It would be AXI plus AYJ cross BXI plus BYJ. Now this is in 2D, but we also do need in 3D. So in 3-dimensional form, if I am taking a vector, okay, if I am taking a vector in 3-dimensional form, then what it would be? It would be like this. A equals to another Z coordinate will be added up, AXI, AYJ cap plus AZ K cap, like this. Okay, I am simply adding another dimension to it, right? So here it is AZ. Similarly, I can write for B. B vector is BXI plus BYJ cap plus BZ K cap. Now I am going to do what? The vector product of it or cross product of it. So there will be three Cartesian coordinates like this, AX I cap plus AYJ cap plus AZ K cap into BXI cap plus BYJ cap plus BZ K cap. Then we are going to have the cross product of it. But before that, we must understand from the properties itself, which we already read, that the vector, the cross product of vector with itself is 0. So if I am taking I with I, it would be what? 0. Same with J cross J. Same with K cross K. They all will be 0. This is the first of it. So I am going to write it here. What are the cross product of orthogonal vectors? So I cap into I cap equals to J cross J equals to K cross K equals to 0. the cross product of vector with itself is 0. So as we are considering the orthogonal vectors as vector itself with a direction sign, so it will be 0. Now what would be I cross j? Very nice question. It would be k. Why so? Because as we already know, if we are taking two vectors, okay, if we know if we are taking two vectors A and B, then we are having the perpendicular as the resultant, which is perpendicular to the plane containing the two vectors. That's why I cross j will be the perpendicular component. If this is I, this is j. So what is perpendicular to ij here? K. Okay. So ij will be k. Again, j cross I will be minus k. You must understand these things because this is very important to know when we are talking in a cyclic manner like this. I, j, k. So from I to j it is cyclic in a clockwise manner. J to k it is cyclic. K to I it is again cyclic. But if we are taking the turn anti-clockwise, like from I to k this way, if I am going this way, then it is going to be minus. That's what I have written here. So I cross j is k, but j cross I, if it is going this way, it would be minus k. This one which is perpendicular to these two, mutually perpendicular to these two. So this is the fact of it. So similarly, I am going to write the other ones also. J cross k is I, but k cross j equals to minus I. Similarly, k cross I is j, the left one which is mutually perpendicular to the other two. Similarly, I cross k taken in reverse or anti-clockwise manner will give to minus j. So considering all these things, what would be the vector product in Cartesian coordinate? How I am gonna write it? I am gonna write it as A cross B equals to, again I am writing AX I cap plus AY j cap plus AZ k cap. Okay, cross BX I cap plus BY j cap plus BZ k cap. I am having the cross product now. When I am having the cross product, if you are very know about determinant, it would be in the form of like this. IJK, I will simply write it as this, like this. Okay, IJK, I down to I, AX, BX, X component will be written in the first column. In the second column, I will write the Y components. In the third column, I will write the components of K, that are Z components. So this is the determinant form. And how to solve it? If I am taking I as common, it will be solved like this. If I am taking, then I will leave this row and this row. So what is left? Left is these will be multiplied with the minus sign. How I am going to write it here? AYBZ minus BYAZ. So what you are doing? You are leaving the X component, JK, you are multiplying AYBZ minus BYAZ. That's it. Similarly, plus for J component, I will write. J component. What I will write? J component will be If I am taking j component, then how I am going to solve it? I am going to erase it so that it will be much easier for you to understand. Okay. So if I am taking j component, then I will leave this row. Okay. I will leave this row. This ay and by I will leave and simply multiply ax bz as it is written in a cyclic manner. So I will simply take it as a minus sign. Remember, for j, for the middle one, I will take as a minus sign and write the answer. Now it is ax bz, because as I have already told, j नेली माने k और k to start हवा कथा, I then j then k. So mu k to start koni mane mu minus te debi. Okay, that's why I am writing this. So ax bz minus bx az. That's it. This multiplied with this, and that multiplied az is multiplied with bx with a minus sign. Now the other one will be plus sign because it is cyclic again. K I am taking, so this row and this column will be left out, and what I am going to write it here? You must know it, ax by minus ay bx. So this is how it will be solved. This is the answer for vector product in Cartesian coordinate, that means in 3D. Okay, so this determinant, if you understood, it's okay. If you do not understood also, please write me down so that we will discuss it together. Determinant will be studied in mathematics in class 11 only. I hope you will understand from my point of view. If also you didn't get it, write in the comment section so that we can discuss. Right? Then I'll move to the next part, which is the important property of it, which is the right hand thumb rule. So basically, what is right hand thumb rule? Now let me draw you a diagram so that it would be very convenient for you to understand. Now the all the formula or description of it is given in your book, that if we curl our finger like this, if we curl our finger, these four are my four fingers, right? So this is my forefinger. If I am curling like this, thumb is like this. This is my right hand, of course. I am drawing. If it shows so, I am not very good in drawing, so I am just showing you. So this is my right hand. Same with the screw also, which is a right turning screw. Okay. So if I am taking two vectors like this, if I am taking two vectors in my right hand, A and B, then I am turning, when I am closing these fingers, it would be like this, in this way. I am curling the fingers like in this direction, this is theta, right? And what will be the product of it? The thumb will show the product, which is C. So C equals to the thumb, which is A cross B. So here you can see that what I am going to show you, right hand thumb rule shows that when we curl the fingers of the right hand, then the thumb erect will give the product of the two vectors. Okay. The rotation from A to B through smaller angle. The rotation from A to B through smaller angle, which is given by theta, and the thumb will show the direction of the product of these two vectors. Okay. So this is the right hand thumb rule, and this is also the right hand screw rule. If I put a screw over here, and A, B are if I am turning the screw in right hand direction by curling our four fingers, and the curling of four fingers will give the direction from A to B, then the perpendicular will show the product of two vectors, and this is called right hand screw rule or right hand thumb rule. Okay. Now there are certain examples I need to discuss with you which are involving cross product in our mathematical explanation. Kids, you can see here there is some confusion regarding the J and its sign convention. You can write it down as simply, I can make it more easier for you, that A cross B equals to, if I am taking I as component, then I will simply write the Y and Z component. Alternate करके लिखिबी ताहले सेटा कोन हबो, then I will know I am correct, I am writing correct. Okay, I am simply exchanging the subscripts. तळे जोटा लिखा है सेटा को ही change करूची, like that. Okay, तापर मु पुनी प्लस साइन को जीबी J कैप लिखिबी. J कैप लिखिले मोर actually एठी AX BZ टा आगो आसुची, which is not in circular manner. So for circular manner I should start with AZ BX. So सेति पे मु minus टा जदी बाहर को नहीं जीबी, if I take the minus out it would be AZ BX. So all is same now. So एटा पुनी subscript change करी BZ AX लिखिबी. Okay. Plus पुणी K कैप लिखिबी, that was always cyclic, so no need to change. बाकी जहाँ अच्छी same रहिबो, this would be more easier for you, I think so. So this is another expression for A cross B in Cartesian coordinates. Now आमे properties रू कौन पढ़ी चे, आमे properties रू पढ़ी चे जितने बड़े दीटा आमे vector नौचे, orthogonal रो आमे already कहे सलेनी I cross I होची 0, same with J cross J, same with K cross K. So सेई गुडा को पके की ही आमे देखिले जेते बळे आमे डॉट प्रोडक्ट वालिया एटा को सॉल्व करिबा, ए टोटल तुमे चाहिले भी करि परिबो, that if we solve this with all this, this with all this and AZK with all this, you will find out this will be the answer lastly. Okay, what I am going to show you now, that if A cross B in any case is happening to be only AB, this is the first case, so I am erasing it, this one, so that this would be more prominent for you to write. Case 1 is when A cross B is AB. So what will be the result? Why it is happening? You must know, when sin theta is 90 degree, that means sin theta 1 hochi tamane theta hochi 90 degree. When they are mutually perpendicular, then only it will happen that A cross B will be AB. Okay, and the lines are giving for magnitude only. If A cross B modulus is giving you 0, then theta could be 0 or 180 degree, as we know. So cross product of a vector with another vector will be a null vector, if they are parallel or anti-parallel. So this is the second case of it. If a vector cross product of two vectors are giving you a null vector, then you must say the two vectors are parallel or anti-parallel to each other. Okay, now Cartesian coordinates bhi hame पढ़ी सालेनी. In next class we will discuss some examples relating to dot products and cross products. Till then I would say ki please like my videos and subscribe to my channel, so that any video I am coming with you will get notification of it. Thank you for watching. Please do not skip the videos. Stay till the end. Take care. Have a good day.